So we have one more terminal means these are the so now you see these are the intermediate layers. So each intermediate layers it has to pass through the activation. I told you this ReLU most commonly widely used in where in RNN. So I already know. So what is this ReLU? So here if you see ReLU is one type of activation function. So I will write like this. So look at this. Observe. Let us say you have two input layers, right? Means 3 layers, 2 layers. So it is coming like this. So from each node it will connect to each node, right? So these 3, correct? So here, what is this? This is weights. This is weights, input weights, right? So what I will say, this value will let us say it is 160. Assume some value. So here it is 55, right? So 160 and 50. So now what I can say here, so this is 160 and this is 55. So what, let us say this is 67. I am assuming some number for our understanding purpose only. Okay. So what is this? So if you make the weighted sum here, weighted sum of inputs. So what is weighted sum of inputs? So what is actually the ReLU definition? ReLU of any function x, I will call it as max of 0, x. So if it is a positive value, max value will be the output to the this one, right? So for example, what is the weighted sum of inputs? So 160 is there, input into. So I will write it like this. This is 0.35. See, x1 is 160, w1 is 0.35. Like that you can see. x1 into w1 is will pass on to the next node, 67, right? So like that. So something, this is 0.2. So this I will consider as 0.7. So coming from 55, I will call this as 0.18. So I will call this as minus 0.4. This I will call it as minus point. Okay, minus weights can be negative also, right? Let us assume. So what is this weighted sum? So 160 into 0.35. So plus 55 into 0.2. How much you got? 60. So this is what? 67. So coming from 0.35, 0.35 into 160, 0.2 into 55, we will get 67. So here it is 0 minus. So what it is? Minus 0.4. Minus 0.4 is coming. So anything negative value is coming, the output will be 0 when you pass through ReLU. When negative values are not considered in ReLU. So here 121. So what is 121? 0.7 into 160 plus 55 into 0.18. This is 120. So weighted sum. So that is how the ReLU non-linear inputs, non-linear transfers will come. So if you plot, so it will be like this. So only positive values will be plotted. So any negative, for example, minus 0.5 will come. This will be extrapolated upwards, and this will be negated to. So only the value will be taken, and that will be modulated to 0. So in ReLU. So ReLU activation function works like this. So why I am telling this? Because most of the time in RNN, each intermediate layers, the activation function will be passed through the ReLU activation function. So output will come. So similarly, one more activation function you have. What is this? Sigmoid you have one more activation function. So what is the formula for sigma? E power x divided by e power x plus 1 or 1 plus sigma. So if you plot, if you give the inputs, so it will be plotted something like this, something like this, right? So something like this. So here 0 is 0.5, this is 1, right? So something like this sigma. So sigmoid function will work like this. So this is a sigmoid activation function. So sometimes instead of softmax here in the neural network, if you see the architecture of the neural network here, you have softmax architecture. Softmax is what? The final layer, final output. Finally, we are passing through softmax. Or not softmax, sometimes sigmoid. It's a very simple problem, sigmoid. Or tan hyperbolic function. Tan hyperbolic function or sigmoid or softmax. So most widely 90% of the time softmax. 90%. There is no hit and fast rule in machine learning or deep learning. We can challenge everything because it's a mathematical models. Mathematical models are always challenged, always fine-tuned. So, but probability is most of the time we use softmax or otherwise sigmoid or otherwise tan hyperbolic function. So, like this. So, if it is a softmax, so let us understand the softmax because that also I will tell you. Next, because if you see the Jupyter notebook, see you understand the deep learning, NLP, you understand the first you should understand the theoretical concept. You may be feeling bored, but without theoretical understanding, code you will get answer everywhere. You will get the answer. You will run the Jupyter notebook, you will get the answer. Understand, try to understand the in-depth intuition behind each model. So that is my intention. Okay. So softmax is there. How the softmax is working? Now let us understand how the softmax is working. So let us get clarity over that. So for example, softmax is also another type of activation function. At the end of the day, so let us say Z1, I'll consider W1x plus bias, Z2, W2x plus bias, Z3, W3x plus bias, Z4, W4x plus. With this only now, say all equations. W plus, that is output. From each layer you are getting, everything is going to be passed on to the softmax function. Okay. So let us say for example you have this cat, dog, hen, others you already know, right? You want to find out cat, 0, 0. Where is dog? 0, 1, 0. Hen represented 0, 0, 1, 0. Means I'm just a bag of words. Other side. And say cat is in this space I'm plotting in it. Dog is plotted here. Hen is plotted in the third. Others are plotted on the fourth. Right? So like this. So what is that? Here four spaces are there. 4 layers I am going to add in the neural network, and I am going to get the output. So that is what I am telling Z1, Z2, Z3, Z4. So like that I am plotting. So let us say, so this is Z1, Z2, Z3, Z4. So 4 layers. So if you are neural network will be of 4 layers here. So like this, 4 layers. So each layer. So what is this? 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1. So each it will passing on through that each activation function you will get. Right? So like that you have. So anyhow you keep it aside that. So here Z1, Z2, Z3, Z4 is there. Right? So now let us say, let us assume the values. I will randomly I am assuming for making you people to understand how softmax works. In reality, it will not means this whatever the assumptions I have made may not be 2, 3. It's not going to be. So let us assume -1. I have given some value. See for a cat, I am giving it 2. Performance dog 3, 10 -1, 4. I I have assumed. So what is this? So these are classes. Let us say class, multi-classification problem. What is this? This is a multi-classification problem. You don't have binary classification, not cat and dog. You have n also. You have other animals also, other birds also, possibilities. So multi-classification problem. So in such case, we use this softmax. Sigma D can't use. You have to use softmax for multi-classification. So as a result, so now you see e power z1, e power z2, e power z3, e power z4, e power z4. So if you go, means I have assumed e power exponential to the power of 2, 7.38, exponential to the power of 3, 20.08, so minus 1.36, 1 by e power x. 4, 54.5, something, some value I got. Okay. So what is this? These are the weights of each classes. Which class? I was means for cat the 7.38, for dog 20, for this one 0.36, for others 54, for others 54. So how many classes? C is equal to 4 we have, 4 classes we have. So what is the formula for softmax? How it is going to calculate? I is equal to 1 to C. I is equal to 1 to C. There are 4 classes, 1 to 4. I is equal to 1 to C. E to the power of Z I, what I can say, e to the power of Z1 divided by summation. Okay, 1 minute. I will write it properly for your understanding. Okay, now, so if I write the formula, summation for what is the softmax? So summation, so what I can say, e to the power of z1 whole divided by summation of c is equal to 1 to c. 4 classes, e to the power of zi, comma, say e to the power of z2 by summation of c is equal to 1 to z c e to the power of zi. Okay. E to the power of z3 by summation of c is equal to 1 to c e to the power of zi. Same, e to the power of z4 by summation c is equal to 1 to c e to the power of zi. So I is equal to 1 here, I is equal to 2 here, c is equal to, I is equal to 3, 4. So whatever it is. So already z means z1. Z1 value is how much? Still 0.38. How much? 5. E to the power of 7.38. Z e to the power of z1 divided by e to the power of z1 already I got 7.3. We assume 2. 2 to the power e to the power of 2 is 7.38. I assume value for z1 as 2. I arbitrarily assume. Okay, I arbitrarily assume for making you to understand the how intuition behind how softmax function works. Okay, so I assume 7.38. 7.38 divided by what is this? E to the power of so you will get this. So this value if you do it, so means summation. So if you do this, how you are going to get? So you are going to get it as 0.0089, 0.24, 0.0043, 0.66, 0.66. So you will get the values like this. So 2 by what is this? You will get the values like this. So plus summation. So e power z1 divided by e power zi. So you are going to get it like this. So zi means c is equal to 2. Z1 plus Z2. Here also you are going to get 3. Z3 means summation. Means this two previous you have to add. Here is Z4. C is equal to 1 to 4. You have to add all three. So these weights will change everywhere. These values will change. So you understand, see this mathematics no one is going to ask. Try to understand how it is. So as a result what is happening, the output. So you are getting different outputs, right? So different outputs. So here different outputs, different weights, different outputs for each activation. So there is the value. If this is going to breach this value, you will get the output. If this is 0.0089, if it is above or below 0.0089, it will predict whether it is 0 or 1. So if it is above 0.24, it will predict whether it is 0 or 1. So like that. So output is a 4 cross 1 vector. Output is also going to be 4 cross 1. So you want to predict, what do you want to predict? Dog or not. So 1 0 1 0 0. So this is where dog. So if this has to be 1, so it has to be above 0.24. It has to be above 0.24. Then only you can say that this is a dog or. But this how? Which is also being considered. Means I am just saying, what I am saying is, means this is how you are calculating. So like this it happens. And also what you can say, the loss, see this is the output you got. What is this output you got? Y hat. Y hat you got. Output whatever you will get, that is also a 4 cross 1 vector only you will get. Because it's a multi-classification problem in softmax. So as a result, what is y? Y is also 4 cross 1 vector only you will get. Y is also 4 cross 1 vector. But here in softmax, what is y minus y hat we usually define as loss. But in softmax function, we make modification to the loss function. What is that modification? That is equal to what is this? Minus summation of I is equal to 1 to c. How many number of classifications are there? Y j log of y hat j. This is how. What is this? The formula for what is this? Loss. Loss is equal to, this is equal to loss. Formula is this one, not this one. Y hat minus y, not this one. What is this? Yj minus loss is equal to, you have made the modifications like that in the softmax function. Who invented softmax? That scientist. He has made it like this. So yj is so the iteration, the first or the second or the third. And we have 4 classes. So what is going to happen here? Minus y1 log y1 minus y2 log y2, y3 log y3, y4 log y4. So out of this only one classification is there. So what is this? What is the output vector? Only dog is there only once. What is this? Y hat. See this value. What is this? For example, I want to predict dog. 0 1 0 0. This y2. Y2 value is equal to what? 1. So here y2 value will be replaced with 1. Remaining everywhere. This is y1 is 0. Y3 is 0. Y4 is 0. This will become 0. This will become 0. This will become 0. So minus 1 into log of 1. What is log 1? Log 1 is 0, no? Y hat. So whatever. So this value will, only this value will y hat. Maybe it may not be, this y2 is actual value. Actual output is 1. But predicted output will not be actual. It is not 1, means 1, there will be something. So some maybe 0.66. So right, so maybe instead of 1, it will be 0.89 something. So as a result, it will be closer to 0. So as a result, we'll see now you see it is almost nearer softmax. It makes sense, right? It is nearer to the predicted value. This is modification to the generalized equation what we have. So softmax activation function, yeah.
So basically in the log, in the brackets, whatever the value comes it will be a y hat, okay?
Y hat.
And
Yeah,
the
y
first
hat.
value is because only the output.
Because everywhere whatever the output you get from machine learning or deep model is a predicted value. Actual output will be y. This y hat only.
Multi classification.
But
So if there will be a 0, 1 or 2 or 3 or
something like that.
As a y,
Y.
y1, y2,
Y2,
y3.
y3.
Y it will be a
predicted output. So this is how the logic behind how softmax activation function is going to work. So I think in this, how to alter the number of layers, what are the different intuitions, what are the assumptions that are made while deriving the softmax functions. The assumptions are made while deriving linear model also. So many things are there. Those are the hyperparameters. Still you can tune, but anyhow we are not interested in that. Almost is a very good activation function softmax that we will be using mostly in RNN, even in CNN also, sometimes even in very advanced level of very optimized activation function. What is this? Softmax, multi-classification. You can use this for binary classification also. You can use the softmax function for binary classification also, not just sigmoid. This also you can. So this is regarding the activation function today. I think you understood the theory behind